Hello everyone, my name is Nazam and today we're going to solve problem number 54 from chapter 23 from the Randall book. Okay, I will put the description of the problem so you can read it yourself first. Let's start. I already drawn the figure in order to save time. Okay, let's see what is given. We have two charged capacitors. One is positive charged and the second is negatively charged. We have an electron that is launched from the positive capacitor at an angle of 45 degrees. It lands 4 centimeters away and the velocity, here we have it, is 5 multiplied by 10 to the power of 6 meters divided by seconds. Okay, let's also write S. As we already said, it lands 4 centimeters away from its initial starting point. Okay, what we have to find? In A, we have to find what is the electric field inside the capacitors. In B, we have to find what is the minimum distance between the two capacitors. Okay, let's see what forces act on this. First, we have the net force that is oppositely directed to the y-axis, and then we have the electric field that is directed by the y-axis. It goes from the positive capacitor to the negative. First, we're going to find the electric field. As we all know, the formula of the electric field is equal to force divided by charge. We know that the net force formula is equal to MA divided by Q charge. Okay, let's see. We have mass. We know that its mass is equal to 9.1 of an electron is equal to 9.1 10 to the power of minus 31 kg. And charge, we know that is equal to 1.6 multiplied by 10 to the power of minus 19 coulomb. Now we have to find acceleration. Okay, what do we need in order to find acceleration? Let's see. In this figure, we have distance, so it means we can find time. S is equal to Vx. Also, I would like to mention that here, there's no acceleration by the x-axis. There's only acceleration by the y-axis. Okay, so let's find time. Here, I wrote the formula for the time. From this, we can see that t is equal to s divided by vx. In order to find the velocity by the x-axis, let's draw the trajectory of the velocities. We have v0. We have the velocity by the x-axis, and we have the velocity by the y-axis. Okay, let's see. Cosine alpha, here we have the angle alpha, is equal to Vx divided by V0. And sine alpha is equal to Vy divided by V0. Okay, from this formula, we need to find Vx. Let's write it. Vx is equal to V0 multiplied by cosine alpha, while Vy is equal to V0 multiplied by sine alpha. Okay, we found what we needed here. Let's outline the formulas. Now let's find time. Here we already were given the distance. Let's use the international unit system. It's going to be 0.4 meters. Okay, 0.04 divided by V0 multiplied by cosine alpha. 1.04 multiplied by, we already have the V0, it was also given here. Let's write it here. It's going to be 5 multiplied by 10 to the power of 6. I have here meters. We have meters divided by seconds. Multiplied by cosine alpha. Our angle is 45 degrees. Okay, as we all know, cosine 45 degrees is equal to sine 45 degrees, which is equal to root 2 divided by 2. Okay, let's write it here. 1.04 meters. 5, 10, 6 meters divided by seconds, multiplied by 2 in a root, divided by 2. Okay, let's calculate this. Let's write this here because we're gonna erase it in order to remember it. -9 seconds. And also let's write those formulas because we're gonna use them later. Okay, here we have time that we already found. And here, let's write the formulas. We're gonna use this formula, so let's just write it. 5 by sine alpha. And let's erase everything else and continue our calculations. Okay, let's use our time to find acceleration. Okay, so we know that in the half of the point, the maximum velocity will be 0 and it's gonna reach its maximum. So we can write the formula. Vy is equal to V0y. We already found it previously, minus AT divided by 2. We know that this point is equal to 0. So now we can transform this formula and write it like this. So what do we need? We need to find acceleration. Acceleration formula is equal to V2 multiplied by V0y divided to t. Let's start the calculations. 2, we know that V0y is equal to V0 divided by sine alpha divided into t. We found it previously here, we wrote it here. 11.4 multiplied by 10 to the power of -9 seconds. Okay. We know that our angle alpha is equal to 45 degrees. And we wrote it also here that sine and cosine alpha are the same at 45 angle degrees. Let's write this. So V0 was given. And here 11.4 multiplied by 10 to the power of -9 seconds. Let's write the answer. 6.2 multiplied by 10 to the power of 14 meters divided to second squared. We've calculated our acceleration. Let's write it to the board. Okay, now let's erase everything. Okay, let's see. To find electric field, we only needed acceleration. Here, we found it. Now, let's calculate our electric field. It's equal to, as we previously said, mass of an electron is equal to 9.1 multiplied by 10 to the power of minus 31 multiplied by our acceleration that we found, 11 meters per second. I'm sorry, here I made a mistake, 14. Now, let's write our charge. Okay, let's calculate. Okay, let's write it. 3.6 multiplied by 10 to the power of 3 newtons divided by coulomb. Here we found the electric field. We needed to find it, so we found it. Okay, first answer. Now let's see what we have to find next. We have to find the smallest distance between the two capacitors. Okay, let's find the H minimum. Here, it's the distance between the two capacitors. Okay, let's use our basic knowledge of mechanics. We know that H is equal to V final plus V initial divided into 2 multiplied by T. Now, we don't have T, but we can write it differently. So T is equal, delta T is equal to delta V divided by acceleration, which we already found. Okay, let's put this in this example. Okay, H is equal to V final plus V initial. Here delta V, we know that delta V is equal to V final minus V initial. V final minus V initial. Okay, now divided by 2, acceleration. Let's write this differently. Okay, now let's continue this formula. We know from basic mathematics that we can write those two like this. V final square minus V initial square divided by 2 acceleration. Okay, now because the maximum point here is the dot here in the middle, we know that it is equal to 0. So we can cross this out and write 0. So from here, the formula is going to look like this. V initial square, 2 acceleration. Okay, now we already found this V initial. It's right here. It's V0 multiplied by sine alpha divided into 2a. Okay, let's continue. We already know that V0 is equal to 5 multiplied by the 10 power of 6 multiplied by sine 45 degrees is equal to this. Now let's write 2, and we have acceleration, which we counted in the previous example. So now let's calculate this. Okay, now we calculated it. It's going to be 0.01 meters, which is equal to 1 centimeters. Now this is the final answer. So, okay, let's revise. Now we found in A, we had to find the electric field in the capacitors. We found it. The answer was 3.6 multiplied by 10 to the power of 3 newtons divided by coulombs. In the second problem, we had to find the minimum distance between the two capacitors. It is equal to 0.01 meters or 1 centimeter. This is the solution of this problem. I hope you understood everything. If you have questions, you can write it in the comments. I will answer them.